Hello and welcome to this online video lecture about specific heat. By the end of this video you should be able to use the formula that relates specific heat to energy and mass and temperature change. You should be able to use that formula to solve problems involving those properties. Specific heat itself, it might be something that you've never heard of before, but basically it's the name that we give to the amount of energy you have to add to a substance in order to raise its temperature 1 degree Celsius. So if we're going to be doing some problems involving specific heat, we're obviously going to have some kind of a formula, and that formula usually is stated like this. Q, usually lowercase q, equals m capital C delta T. So Q equals MC delta T. So what the heck are Q, MC, and delta T? Well, Q is the amount of heat energy gained or lost. So that's the heat energy term. M, as you might be able to guess, is mass. Capital C is the specific heat. And then delta T is change in temperature. And another way to state that term is to say that it's the final temperature minus the initial temperature. It's the same as saying delta T. And that's going to become important here in a second. So basically, specific heat itself is this, this capital C, and it's the amount of energy that's required to raise the temperature of some material, some mass of material, 1 degree Celsius. So that's kind of how all these things are related to each other. That formula right there. Well, since you have your formula, really the rest of this video boils down to me showing you examples of how you would resolve that for one of those terms and plug in numbers and get your final answer. If you feel pretty confident that you can take that formula up to a quiz and do that algebra yourself and get the right answers, you could probably stop watching now if you feel confident in that. If you don't feel confident in that, watch a little bit further, and I'm going to give you a few examples of how to resolve that and get one of these 4 different terms here. So this is the idea that's new here is specific heat. So the first thing I want to do is I want to show you an example of how you're actually solving for the specific heat. So the specific heat is C. So what I'm going to do is I'm going to solve Q equals MC delta T for C. And so in order to get C by itself, I have to divide both sides by M delta T. So Q over M delta T equals C. So the specific heat is equal to the heat gained or lost divided by the mass of the sample and the change in temperature. That's going to give you the specific heat. So what does that have to do with anything? Well, let me give you an example of like a word problem. I think that's probably the easiest way to do it. So let's say I have a metal, and the mass of the metal, let's see, metal, well, let's see, let me try that again. Let's make this more word problem-y. So let's say you have 26.86 grams of some metal. And it absorbs, let's say, I don't know, just make a number up, 418.6. 418.6 joules of heat energy, and its temp rises from, let's say, I don't know, 27.4 degrees Celsius to 67.3 Celsius. what is the metal's specific heat? So here we go. This is the type of word problem that you're going to see probably on the quiz. One example of these in this one, after you read it, you should identify that the problem wants you to solve for specific heat. So you would go back to the original equation, you'd solve it for specific heat like I did right there, and you'd see that the heat energy absorbed or lost divided by the mass divided by the change in temperature equals the specific heat. So I'm just going to take that formula, I'm going to rewrite it right down here. The heat energy divided by the mass divided by the change in temperature equals the specific heat. So let's plug our numbers in. So the heat gained, the heat energy gained is 418.6 joules. That's a point. There we go. And we're going to divide that by the mass, which was 26.86 grams. And then we're going to divide it again by the change in temperature. So we went from 27.4 to 67.3. So let me just grab my calculator really fast. Whoop. So we went from 27 point, oops, I gotta clear that out. The final temperature is 67.3, and then we started at 27.4. That gives us a delta T, or a change in temperature, of 39.9. So let me write that on there. Okay. So now what do we have? We have 418.6 joules divided by 26.86 grams divided by 39.9 degrees Celsius. So let's do that now. So it's 418.6 divided by 26.86 divided by 39.9, and we get looks like about a 0.3 here, so 0.39, so 0.39. Now the unit on specific heat is pretty crazy. As you can see, it's joules per gram degrees Celsius, which is kind of crazy, but that's basically what you get when you divide that out. And that's an example of how you would solve that problem and you get that answer, 0.39 joules per gram per degree Celsius. So that's an example of doing specific heat. And as you can see, all I did is I went back, just like you had to take a quiz on. I had to resolve this original equation for the specific heat itself and then plug in my numbers and go. Now what does that mean? That means that for this specific metal, 30.39 joules will raise 1 gram 1 degree Celsius. That's basically what this unit right here is saying, per gram per degree Celsius. So every 0.39 joules of energy that you add, however you add it, is going to raise the temperature of that metal 1 degree Celsius. 1 gram of that metal, 1 degree Celsius. That's what specific heat is. So I think what I'm going to do, I'm not going to go through and I'm not going to resolve this equation for every single one of the terms. That would be kind of silly. You guys at this point should be able to do that algebra. But one thing I am going to do is one that's a little tricky, and that's I'm actually going to solve for maybe like, maybe a final temperature. I think that might be kind of interesting because final temperature is hidden. Remember, final temperature is hidden inside of this delta T term. It's right there. It's inside of that. So what I'm going to do is I'm going to come down here and let's write out a problem here for a second. I'm going to go ahead and pause the video as I write the problem out because it just wastes time and you guys don't need to listen to me say the problem out loud as I write it. So I'll write it out and I'll be right back. Okay, got that all written out and now I'm back. So here's an example of a word problem that's a little bit, probably the most challenging you're going to encounter here. This one is actually, as we're going to see in a second, is asking you to find the final temperature. I'm going to show you why that's a little tricky. But let's just look at this word problem. A 38 gram, 34 degrees Celsius sample of water releases 1,621 joules of energy with a specific heat of 4.18 joules per gram Celsius. What is the water's final temperature? So, excuse me, by reading through that word problem, we can cue in the what is the, it's telling us what we're going to have to try to find. What is the water's final temperature? Final temperature is TF, and it hides in the basic formula that I gave you earlier at the start of this lecture. So if we look at this formula of Q equals MC delta T, the TF is hiding in the delta T, because remember delta T is TF minus TI. So I'm going to erase the delta T, and I'm actually going to put the TF minus TI right there. So I'm going to put it in parentheses, TF minus TI. All right, so now I want to get TF by itself. Mr. TF right here. So what am I going to do? Well, you have to remember you do your order of operations in reverse order, so we're not going to go into those parentheses first. That's a term. We're going to try to get that isolated before we can do anything with it. So what's with the TF minus TI? M times C. So the first thing I'm going to do is divide both sides by MC. So I have Q over MC equals, and then we just have our, I don't even have to use the parentheses now at this point. We just have our TF minus TI. That's our temperature change. Let me scoot this up a little bit. So now I think you can see that the only thing left to do is to get rid of the TI, so we add TI to both sides. And so we get, let's scoot it up a little bit more, Q divided by M divided by C plus TI equals TF. So that's the formula we're going to have to use to solve our word problem. So now I'm going to do it over here, but let's go back up. Let's see what some of these variables are. We need a Q. So Q for this problem is 1,621. So 1,621 is our Q, divided by, we need M and C. M is 38, and C, oh, it's down here. Specific heat is 4.18. So 38, and that's times, let me scroll back up, 4.18. So 38 grams times 4.18, and that's got that crazy unit. And the last thing we need is the initial temperature. So it looks like the initial temperature of this sample was 34 degrees Celsius. So once we've done all that, we're going to add 34 degrees, and that's going to equal our final temperature. So again, I need my calculator. Let me clear all this stuff out. And what are we going to do? We're going to do 1,621, and we're going to divide that by, 1,621, and we're going to divide that by, now I've really messed things up. Let's try this again. 1,621, and we're going to divide that by 38, and then we're going to divide that by 4.18. Remember, if it's in the bottom of a fraction, you divide. So I'm going to hit equal, and I get 10.20, and then to that I'm going to add 34 degrees, and I get my final answer, which is 44.205, so 44.20. So TF equals 44.20 degrees Celsius. Bam. There you go. So I've walked you through the formula and what all of its terms are. We talked about Q being the heat energy, M is the mass of the substance, C is the specific heat, which is what we are kind of learning about here. Delta T is the temperature change, the final temperature minus the initial temperature. We talked about resolving that, and I walked you through 2 word problems on how to do it, and hopefully you now are able to do that on your own. But as always, if you have any questions, please, please, please feel free to ask in class. Thank you for watching, and take care.